Okay, we're in part 2 of our exploration, what I call Beyond Newton, and we're going to discover what we mean by the plasma universe. It's interesting, there's a quote in Psalm 19 we'll be talking about, which speaks of the sun. His going forth is from the end of heaven and a circuit unto the ends of it. And that's exactly what we see happening in the sky. People say, well, the sun doesn't rise in the morning and set in the evening. The Bible's wrong. No, it's taking a global view because the sun is moving in a circle itself. Let's just review something we talked about earlier. I want to focus in on that, the kind of beliefs that we hear talked about in astronomy. There's a black hole in the center of that galaxy. Otherwise, we cannot explain the level of its energy output. Oh. Well, there's invisible dark matter in that galaxy. Otherwise, we cannot explain how it rotates the way it does. See, they have to postulate that to explain to confirm their theories. 96% of the universe is made up of dark energy and dark matter we cannot see. Really? You'd think that would make us at least suspicious. See, otherwise, the clusters of galaxies would fly apart because gravity alone can't hold them together. So it never occurred to them that it might not be gravity we're looking for. They just figure if gravity alone can't do it, there must be more gravity somewhere, more mass. Pulsars are made up of strange matter. Otherwise, we can't explain their oscillator-like behavior. Really. Photographs of connections between two objects that have different redshifts are only chance alignments. Really. And the examples are, there's a couple of galaxies that are clearly different redshifted, which means they're way apart, line of sight-wise, and yet they're connected. They can't explain that. Well, that's just an accidental co-occurrence, really. Otherwise, the Big Bang is falsified. Oh. As Halton Arp was Edwin Hubble's assistant and longtime observer at Mount Palomar and Mount Wilson telescopes, his photographs contradict the Big Bang theory in the first place. You think they would get suspicious. Well, that's what we're going to get into. There are myths in the midst here. The illusion of there's only one certain barrier to truth, the conviction you already have it. The greatest obstacle to discovery is not ignorance, it is the illusion of knowledge. Metaphors reign where mysteries reside. Science versus technology, we talked about in the previous session. And technology produces useful products. That's where the economy rewards that. Science has become a religion with a priesthood. The astronomers are really in a cul-de-sac of myopia or nearsightedness. Astronomers explain their views relying on 17th and 18th century tools of their forefathers, Kepler and Newton. Gravity, fluid mechanics, the magnetism of lodestone, rather than those of the 19th century, James Clerk Maxwell and the electromagnetic field theory. You see, they're a century lagging here. Furthermore, the astronomers are not actually empirically based. They choose to ignore data that isn't consistent with their conjectures. They must postulate particles not seen, gravitons being the example, and forces not yet experienced. Well, that's ignoring the absence of that information. Sir Isaac Newton, he wrote Principia back in 1687. It translated, it was in Latin, then in English 1729. Gave the foundation of calculus, extended the understanding of color and light, mechanics. But his big thing was the inverse square law of universal gravitation. That inverse square law. We talked about this last time. We're going to pick up on this now. That's the equation. Okay? M1 times the product of the two masses divided by the square of the distance between them. That's the thing that you want to keep an eye on. Well, the astronomers like to talk about gravity waves. There's millions and millions of dollars being spent on equipment searching for the gravitons. Relativistic gravitational field theory implies the existence of particles called gravitons as carriers of the field. They're massless, uncharged particles moving at the speed of light, but so far undetected, so we've got to spend money to detect them. Try, okay? The GE600 project in Germany is an example of that. What they have discovered, that we may be in a holographic universe, whole other study. We mentioned that in the previous series. The Burnham model, we took that last time, but to get it fresh in our minds now, we've got, we're going to use inches in the statute mile to represent astronomical units, okay? The distance of the sun to the earth is an astronomical unit. So 1 inch represents the distance from the sun to the earth. 1 mile represents a light year. And this is from the Celestial Handbook. That's a standard thing in astronomy, but adopting this to get a perspective is useful here. If you take the sun as 1/100th of an inch in diameter, so it's a speck the size of a period, all planets are then inside a 7-foot circle. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and then Pluto are all within a, going to diameters now, twice that. In other words, it's a meter in radius or 2 meters in diameter. Call it 7, 8 feet. Well, the nearest star is 4.5 light years away from us. So on our little model, we have to put a speck the size of a period 4.5 miles away. What do you suspect, according to Newton's law of gravity? You take the product of their masses, divide by the square of the distance between them. What have you got left? Nothing, really. 2 specks of dust 4.5 miles apart. If you can more comfortable visualize them as golf balls, they are 700 miles apart. How much gravity do you think 2 golf balls, 700 miles apart, feel towards each other? Okay, so see, what everybody overlooks is this d squared. The distance between them, you take it and you square it. That's a second order function here. Back in our discussion of fundamental forces in beyond perception, we talked about electromagnetic and weak forces. Gravity is 10 to the minus 38. Electromagnetic is 10 to the minus 2. What does that mean? That means the electromagnetic force is, that's oodles, 10 to the 30. Those are orders, it's not 10 times as big, it's 10 with 38 zeros after it, bigger. And not only is it incredibly more strong, it also, in both directions, it's positive and negative. It can repulse. It not only can attract, if they're unlike charges, they can push each other away. The electromagnetic force, whichever way it is 36 orders of magnitude beyond gravity. Okay? So it's what's ruling, not gravity. Gravity is, once you start dealing in these large distances, gravity evaporates into irrelevancy. Electromagnetic is what it's really all about. And that's been ignored by the field of astronomy for some very interesting reasons. This aurora we mentioned before is just indicative of the kind of physics phenomena. When we go to some of these little toys, like the little display thing there, you put your finger on that. You can play when you get a chance after the thing. You can go play with it. Just put your hand on it. You'll see the filaments there, the plasma filaments follow you as what you're doing, and it's obviously not gravity that's doing that. We talked about the fathers. We went through the different guys, Faraday and Newton and so forth. Let's pick up the founders now of plasma. Christian Birkeland. He made a heroic commitment gathering data from aurora displays. He was the first to recognize that electric currents flow from the sun to excite plasmas in the Earth's upper atmosphere. We call those auroras. He studied them. The Brits chose to ignore them. The Swedes and the Norwegians studied them a lot and made all kinds of exciting discoveries. And Birkeland is a legend in this field. He discovered the twisted corkscrew-shaped high-intensity currents in plasmas that follow magnetic fields rather than cross them. These are called Birkeland currents. I'll show you some in a little bit here. He was nominated for the Nobel Prize in Physics 7 times. His portrait remains on the 200 kroner Norwegian currency to this day. You've got a 200 kroner note, you'll see his picture on it. He's a legend there, unheard of in the Western culture, or I should say the British culture. Well, he's followed by Erwin Langmuir. He discovered what's called the double sheath or double layer in plasmas, and I'll get to that in a minute. He coined the term plasma. He's the one that many people just call it ionized gases. he coined the term plasma because these are they're not like they're different than a gas because they're electrified. And he used the word plasma to describe these almost lifelike, self-organizing behavior of these ionized clouds in the presence of electric currents, magnetic fields, foreign bodies that are inserted to them. You put a foreign body in them, and it surrounds them and double sheaths it. And that's what he discovered, and it's named after him. He invented the Langmuir probe, still used today. Now, let me explain what these double layers are. One of the most important properties of a plasma is its tendency to isolate one section from another electrically by a wall of two closely spaced layers, one of positive charges, the other of negative charges. And a DL, as it's called, or double layer, is where the strongest electric field in any plasma will be found. The plasmas will isolate themselves from foreign intruders by surrounding themselves with a double layer as a protective sheath. So you plunge a sphere in there, and the plasma will enclose it, if you will, with a double sheath. And that has some very unusual behavior I'll come to in a minute. Well, after Langmuir, then Langmuir, he invented a probe that was a way of measuring what's going on inside the double layer. That's called a Langmuir probe to this very day. It's a clever device that he invented. But here's the big guy. This is the guy who's just a legend. He just died in 1995. Hans Alfvén. And he was the first to predict the large-scale filamentary structure of the universe back in 63. Now, there's two things about that. They've known about this some time, on the one hand, over 40, 50 years, 60 years. But it's also interesting, these fathers of science are recent. They're our generation, so to speak. Maybe not yours, but my wife and I, anyhow, okay? So science has gotten contemporary with plasmas. He first proposed the mechanism for the acceleration of cosmic rays, now known as the Fermi mechanism. He was awarded the Nobel Prize in Physics in 1970 for his work in magnetohydrodynamics, a closely related field. In February of 1981, 11 years after the Swedish electrical engineer Hans Alfvén won the Nobel Prize in Physics, he published Cosmic Plasma, a book which has been largely ignored by the astrophysics community. That's what's so amazing about this. People aren't open to new ideas. This was seen as a threat, then they dismissed it rather than embraced it, or even just evaluated it. Yet our space probes have since confirmed his views. Over 99% of the universe is composed of electric plasmas, and they obey the same physical laws as small laboratory plasmas do here on Earth. Okay, now that little thing down there, the little toy we showed you, is just a toy, really. Don't confuse that with a laboratory thing, which is far more elaborate, but nevertheless. Then we have Anthony Perrott, author of a book called The Physics of the Plasma Universe, Numerical and Experimental Contributions to High-Energy Density Plasmas and Intense Particle Beams, Explosively Driven Pulse Power Generators, that sounds like weapons to you, lasers, intense power, microwave sources, particles, high-energy density phenomena, Z-pinches, I'll come back to that, and inertially driven fusion target designs. At Los Alamos National Laboratory from 1981 to the present, serving the Applied Theoretical Physics Division, Associate Laboratory Directorate for Experimental Programs, and a scientific advisor to the United States Department of Energy, where he served as acting director for national security and so on and so forth. His large-scale simulations of the Maxwell-Lorentz equations yield results virtually indistinguishable from astro images of actual galaxies. You want to see a few? There they are. These are simulations he's done in the laboratory demonstrating the same behavior, and I won't go through all the step-by-step what's going on here because it gets into some other issues too. But basically the main point of this is his simulations in the laboratory fit the behavior that we observe in the heavens, millions of light years away and all that. Well, back to the atom that we talked about before. As you know, we went through this, that if you take the volumetric ratio of what's going on in the atom, you've got a ratio of physical things to space, the same ratio as 1 second has to 30 million years. It's mostly empty space, but what it is, it's electrical charges. It's electrical field. That's what's really the relevant thing that's going on here. And we talked about how molecules, we did this just by way of review from last time. We'll keep moving here. If you cool the plasma, well, first of all, you have these molecules that start attracting electrons. When they pair up, they cool down, they pair up, they become a gas. But that's a different thing. The gas cools down, it becomes a liquid. And as the liquid cools down, it solidifies what we call a solid. And if this happens to be a H2O, then it's ice, and it shows up in the crystalline form as one example of that structure. Now, these four states of matter, solid, liquid, gas, plasma, are plasma is the most disordered, random aspect. As you cool it down, it gets more orderly. Solid is very, very orderly. If you heat it so it's fluid, it gets a little disorderly, it's called liquid. It doesn't have a shape. And then you get the gas, where it'll just expand to whatever volume is available. And then you have the plasma, which is a creature of its own kind. And that's what most of the universe is, plasma. And so the effects of gravity on a plasma are minuscule. They're eclipsed by the electromagnetic forces on them, which we tend to the 39 orders of magnitude difference. And so the entire volume of our entire galaxy is filled with diffuse clouds of magnetized plasma that is electrically charged ionized particles. 99% of all plasma, of matter in the universe is plasma. And last time we looked at Andromeda, when you look at that in infrared, you begin to see the electrical behavior that's actually accounting for what's going on there. And M82, again, if you look at it, it depends what frequencies you're looking at, that'll determine what you see. Here you begin to recognize that you've got electrical factors going on enormous distances away from these that are affected by that. They're behaving together. It's interesting to me that in Job, God gives Job a science quiz in chapter 38, a very interesting chapter, but one of the things he challenges Job about, canst thou bind the sweet influences of the Pleiades or loose the bands of Orion? Well, you can quickly do some calculations and you discover the stars that make up those constellations are so far apart that gravity isn't binding them together. And God is challenging Job. Who do you think you are? Can you explain what ties that together? No. He knew nothing about plasmas. Okay? In Genesis 1, we have the firmament, the waters above the firmament, the waters below. Waters is the Hebrew term mayim. Does it mean really waters, or could it include plasmas? And that's something I'll let you sort out for yourself. Here's another galaxy where you can clearly see the electrical effects. And we'll understand that better as I get into plasma. James Clerk Maxwell, ranked with Sir Isaac Newton and Einstein for their contributions in quantum theory, electromagnetics and electrostatics, thermodynamics, information theory, that's going to turn out to be the key one, and cybernetics. Now, the Maxwell equations are these four equations. They're differential equations. I spare you the math, just to give you a flavor, though, that they relate the electric and magnetic fields to their sources, their charge density, and their current density. And these equations can be combined to show that light itself is simply an electromagnetic wave. Photons of light or photons of an RF signal, they're photons. The interactions of the electrostatic and electromagnetic forces are non-intuitive. In other words, they behave in ways you wouldn't suspect unless you've played with them a little bit. Okay? The forces are orthogonal to the fields. You have a field, the force that field has is 90 degrees in a different direction. We think of a force, if I'm pushing on this, you're expecting it to yield the way I'm pushing. No, if it's a magnetic field, the force is 90 degrees to that. The resulting plasma of these things then take on a unique aspect as a composite body with a very distinctive character of its own. And that's what throws us. Individually, the equations are known as the Gauss's law for magnetism, Faraday's laws of induction, and Ampere's law with Maxwell's correction. And there's another law, the Lorentz force law, that with this package, you have to master if you're going to be in electrical engineering, and they do. But applying it to this is then more easy to do because you'll have some intuitive feeling for how those laws work. The Maxwell-Lorentz law, and there it is for those of you that are curious about it, simply says the acceleration, what they mean by that, the time rate of change of momentum experienced by a particle moving with a velocity v in a magnetic field B that is carrying, is simply the sum and then the product of that. It's very straightforward. No d squared divisor here. It gets strong. As these get stronger, it gets stronger, right? The force experienced by the particle will be at right angles to the direction of its velocity. In other words, the magnetic field is in one direction, the velocity of the particle is in another direction, the magnetic force on the proton is the other. These are all orthogonal to each other, which makes it hard to visualize until you've played with it a bit, okay? What engineers quickly learn is what they call the right-hand rule. And you have if you take your right hand and put your thumb in the direction of the current, your fingers are pointing in the direction of the field around it. If you have a field that's changing, then you'll have a current. If it's increasing, the current will go this way. If it's decreasing, it'll go the other way. But the point is, the right-hand rule allows you to connect the field around that wire. If you have current going through, it'll create a magnetic field. If you have just a wire and you have a magnetic field and it's static, nothing happens. But if the field gets bigger, either stronger or weaker, current will occur. If it's getting stronger, current will go that way. If it's, you get the idea. Okay. So plasma turns out to have 3 different modes. There's a dark current mode. You don't see it because it's invisible. There are plasmodes around us probably that we can't see because they're very low intensity. The Earth's ionosphere, except during auroras, that's when they become visible. The ionosphere is what allows us to send radio waves around the world. If you send a radio wave, it goes out into space. But if you hit the ionosphere and it bends it, it's a form of plasma. It's invisible. You don't see the ionosphere. But if you're a radio ham, you know when they're there. It's old news. Okay. The electric current in a dark current mode is very, very low current. If you get more current, then it starts to emit light, okay? And that occurs in auroras. That occurs in emission nebula, in the sun's corona, in comet trails. Those are plasmas that have enough energy that they're glowing. You have a fluorescent light. You've got plasma operations going in. That's why it's cold. It doesn't get warm. But it's because it's the plasma effect that's giving you the illumination. The brightness, it depends on the brightness, the intensity of the current, and the density of the plasma. All those will affect, and depending on what kind of atoms, what color it is, and so on. Neon lights are an example. The color depends on what gas is being ionized. Well, then there's the third mode. That's the arc mode. And that's what we think of as lightning, for an example. Extreme brilliance and wide spectrum. Electric weldings. When you see someone with electric welding, you never look at it with your eyes. You can ruin your eyes doing it. That's why they wear special glasses. But an arc welding is a danger to spectators. You should understand that. The sun's photosphere. You never look at the sun directly. Lightning and sparks are another example of that. Now they're characterized by twisting filaments and also a lot of ultraviolet and radio frequency as well as what you can see. Now what they discover, they discover is a thing called the Z-pinch effect. High intensity electric current passing through a plasma will take on a corkscrew or spiral shape. That was discovered by Birkeland. And he's famous. They call those now Birkeland currents. The most often occur in pairs. They tend to compress between them any material, ionized or not, in the plasma. And that being pinched in there is called the Z-pinch. Just a name for it. And cosmic matter that you see out there tends to form an abundance of filamentary, stringy structures. And the initial velocity, if a particle is perpendicular to the magnetic field, the path the particle takes is a circle in the plane perpendicular to that field. Great. However, if the velocity of the particle is at a slight angle different than 90 degrees to the magnetic field, perhaps slightly in the same direction of the field, the path will then be a helix or a spiral. If it's exactly perpendicular, it makes a circle. If it's slight angle, it makes a spiral. It's logical, okay? The stronger the field is, the smaller the radius of the circle will be. No matter what the initial direction of the current stream, it will end up following the direction, of course, of the magnetic field. And here's what it looks like. In other words, if you got, they come in pairs, and they'll twist themselves into what you and I would call a helix. That's showing on the left side of that diagram. If you have a bottom view, you see not only are they weaving together, they're tightening themselves together. And what gets caught between them is anything caught there, whether it's plasma or not, gets squeezed. It gets squeezed hard enough to become a material. It may be ionized, but then it becomes it moves to the solid state. And that's the way you can start to create planets electrically. Okay, as an example, or parts of it. The Birkeland current, born in both in the laboratory and in the cosmos, a pair of such spiraling currents will be observed. The interlinked pair will at first be magnetically drawn together, but after a certain proximity is achieved, a force of repulsion is generated that holds them apart. This configuration turns out to be extremely stable, interestingly enough. The resulting tightly wound pair is called a Birkeland current. That's a term used for these pairs, these filamentary pairs. The attractive and repulsive forces acting on this pair of currents creates a twisted, constricting cylindrical volume inside the spiral where extreme compression of matter can take place. When this occurs in cosmic space, the associated plasma filaments can be observed by the radiation they emit. It isn't necessarily in the visible range, but it's measurable. We also have a thing called the Markland convection, when several different chemical elements are contained within such a region of compression. They don't mix homogeneously. They tend to distribute themselves radially according to their ionization potentials. They have an electrical ionization potential, and that will determine how they rank order themselves. 24 million electron volts, it's helium. 13, it's hydrogen, oxygen, and nitrogen. 11, it's carbon and sulfide. And then you got the metals, ferrous and silicon and magnesium and so forth. This is called the Markland convection. We think of convection in terms of heat and our heaters rising. So this is a different thing in plasma physics. It has to do with their ionization potentials. Well, let's talk a little bit about the fabric of space, because that's what we're really into here. What's really going on in space? Stretching the heavens. Is that just a metaphor out of the Bible? He alone stretches out the heavens in Job 9. Stretching out the heaven like a tent curtain in Psalm 104. He stretches out the heavens like a curtain and spreads them out like a tent to dwell in, Isaiah 40, verse 22. He stretches out the heavens, Jeremiah 10. Is this just an idiom all through the Bible? Yes, it is an idiom all through the Bible. Nothing in the Bible is accidental. It's all there deliberately. The Lord who stretches out the heavens. We could go on with these. All through the Scripture, we see the heavens stretched. In fact, we discover that space is not what most people assume. It's not an empty vacuum. We discover in the Bible it can be torn in Isaiah 64. It can be worn out like a garment, according to Psalm 102. It can be shaken in Hebrews 12 and Haggai 2 and Isaiah 13. It can be burnt up, Peter warns us in his second letter. It can split apart like a scroll, Revelation describes. It can be rolled up like a mantle in Hebrews 1, or like a scroll in Isaiah 34. Are these just figures of speech? I don't believe so. I think they're glimpses. This is metaphors reign where mysteries reside. Many of these things might be mentioned by a rabbi as a remez, a hint of something deeper. Let's talk about this idea of rolled up in a scroll. In order for something to be rolled up, there has to be a dimension in which space must be thin. And in order to be rolled up, it must be thin in some sense, and yet it must be able to be bent or rolled. So the very fact it can be rolled up implies there's an additional, whatever space dimensions it has, there's an additional one for this to take place in. If you visualize space as 2 dimensions, you can see it rolled up. But we know that space is 4 dimensions. Okay, then it's to be rolled up, it must be 5. There's got to be a space in which a dimension that space that can be accomplished. So there is a direction in which it can be bent toward. Thus, there are additional spatial dimensions, and 10 is a current estimate by some. That's an estimate by modern particle physicists. It was also the conclusion of a Hebrew sage that wrote in the 13th century from his study of the Hebrew text of Genesis 1. Well, beginning back to space as we know it, there's a thing called the red shift. Back in the 20s, a guy by the name of Edwin Hubble suggested that the reason some stars are shifted to the red, and I'll come back to that in a minute, he called that the Doppler effect as an explanation. And that is still to this day the belief of most astronomers, that the reason stars are shifted to the red is because they're racing away from us. It's like a Doppler effect of a siren. When a siren comes at you, it raises in pitch. When it goes away, it lowers in pitch. they say that it's sort of like that. Well, maybe not. In 1976, William Tift of the Stewart Observatory in Arizona noticed, for over 20 years actually, he documented what he calls aberrant and the digitized nature of the red shifts. You know, the red shifts, some of them aren't shifted to the red, they're shifted to the blue. So they're coming at us, not going away, if that's your explanation. Also, it's digital. It's like a piano. There's certain keys you can hit. You can't get between them. I'm not talking about the black notes. All the keys, they're digital, really. Piano's a digital instrument. When you hit a key, you get a specific frequency. And you hit the next one, you get a different specific frequency. You can't get, not like a violin where you get between those. Okay. And so, in the 1980s, Guthrie and Napier at the Edinburgh Observatory spent 10 years challenging his view and confirmed that Tift was correct. That they can't be the Doppler effect. There's something else going on. And we get into the Rydberg formula. The Rydberg formula was invented by a Swedish physicist, Johannes Rydberg, and presented on November 5th of 1988. It was used in atomic physics to describe the wavelengths of spectral lines of many chemical elements. Every chemical element has a certain barcode, actually. I'll show you one. The barcode of the atom. This happens to be hydrogen. It's on a logarithmic scale, by the way. Every unit is 10 times the previous. You know, you go 10 meters, 1,000 meters. You have to understand what a logarithmic scale. Anyway, there are certain lines. If you hear those lines, that characterizes hydrogen. Now we discover that sometimes it shows up shifted just a smidgen to the red. And they always assume, well, that's because that atom is moving away from us. Maybe, maybe not. Maybe something else is going on here. These spectral lines are due to the electrons moving between energy levels inside the atom, according to Barry Setterfield and others. Robert S. Millikan in 1925 noticed that the wavelengths of spectral lines were shifted from their theoretical positions and was among the first to recognize the energy in space was battering the atoms and affecting their movement. This energy came to be called the zero-point energy. Now this gets to another issue. If you take a cubic meter of space and you take all the matter out of it, there's nothing there. You got a vacuum. Not quite. It still has a temperature. So you cool it. You got it totally empty, and you cool it down to what's called absolute zero. You discover, the shocking discovery is there's still energy in it. And they call that the zero-point energy. And the amount of energy that's in that is gigantic. And that's where any atoms in that space get its energy to keep on its orbit without spinning out or falling in. You ever wonder about that? You know, it's spinning around. It's attracted, it's negative, it's positive, it should be attracted trying to fall in, but it's got energy that's keeping it separated because of the zero-point energy. Max Planck in 1911, and then Einstein, Stern, and Niepce all recognized that this pervasive energy was a universal phenomena and intrinsic to space itself. There's probably, I wouldn't be surprised if you'll find probably less than 1 in 100 astronomers that know anything about the zero-point energy. There's a lot of people, unless you're into physics, in this way, you probably wouldn't know anything about it. Through the work of Heisenberg and others, it began to be understood that Planck's constant was actually the measurement of the uncertainty in the position of atomic particles. All atomic particles are being battered by that energy, and therefore their actual position is ambiguous. It's a statistical issue, in effect. In 1962, it was realized that this uncertainty of position was caused by the battering of the zero-point energy. People talk about the Heisenberg uncertainty principle, and most people talking about it don't know what they're talking about. What they describe is correct, but it isn't the cause. New Agers pick up on this and apply it philosophically. No. It's a specific physics phenomenon. The energy is independent of temperature or mass, and that's a shock to many people. In 1987, Al Puthoff showed that the electrons stayed in their orbits and did not go either spinning out or spinning in due to expended energy, precisely because of the energy they received from the zero-point energy. Using 25 different methods, 475 measurements on 11 different related quantities confirmed the following. By the way, you all know about E equals mc squared. E is for energy. This is the Planck constant. E is equal to the Planck's constant times the speed of light. What they've discovered, as the speed of light slowing down, the Planck's constant increases. The mass of all the atoms increase. But always such that the product, the energy, stays the same. That's a recent discovery. Planck's constant, h, is increasing, and the velocity of light is decreasing. The energy, of course, stays constant. There's no energy made or lost. It's the fixed. But what we discover, as the speed of light's been slowing down, the mass of the atoms are increasing, among other things. So we discover that space has properties. The zero-point energy is about 10 with 95 zeros after it, ergs per cubic centimeter. It has permittivity. It has permeability. These are engineering terms, but there's a dielectric constant, there's a magnetic constant. These are all out of Maxwell. It has an intrinsic impedance. Any amateur radio knows that you have to tune your antenna to the impedance of space. It has properties of its own. Not because of the atoms that are in it. The space itself has properties. It can be stretched, like the Bible says. The velocity of light at creation was over 10 to the 10th power faster than it is today. Currently it's at the speed of gravity, and all that is changing, strangely enough. Well, let's get to epistemology. We talked about epistemology a little bit. Let's go to epistemology part 2, if you will. The final frontier of all sciences we now discover. You study advanced science, you'll quickly discover whatever field you're in, you're going to get confronted with what's called the information sciences. The boundaries of our reality are information. Quantum physics, the Heisenberg, Schroeder's cat, and all that business has to do with information theory. Microbiology. You're going to go into the microbiology, you're going to quickly discover your world is full of coding theory, switching theory. The DNA is a 3 out of 4 error-correcting code. And they can't explain the origin of life because they can't explain the origin of information, which is the antithesis of randomness or the absence of information. And the whole idea of the intelligent design debate is insanity, because by definition, randomness is the absence of design. You can't attribute design to randomness. You're stepping on your own foot. Randomness is the absence of design, and when you find elegant design, it can't be attributed to accident or randomness. So that's another refutation of evolution. In the astrophysics, we have now the fabric of space. It turns out to be an information issue. We now are discovering, or beginning to suspect, maybe more accurate, that our universe is holographic. It's like a giant hologram. It's a giant illusion. That's what David Bohm, a confrere of Einstein, wrote about because he was with Einstein. They were good buddies, but Bohm came out of the plasma world. He was known for his work in plasmas. And he's the one that has first formulated that, and now it's starting to gain credibility because of the discoveries they've made at the GEO 600. And so we're now talking a lot, what we've been talking about is the plasma universe. And it's interesting to me, as my personal field has been, in obviously a very modest way, the field of information sciences. And because of that, I've always been attracted to Psalm 19, which we'll just take a few verses of it. Psalm of David. The heavens declare the glory of God, and the firmament showeth his handiwork. Day to day uttereth speech, and night unto night showeth knowledge. There is no speech nor language where their voice is not heard. Their line has gone out through all the earth, and their words to the end of the world. Wow. Notice something. The heavens declare, the firmament showeth it. Day to day uttereth speech, night showeth knowledge. There is no speech nor language where their voice is not heard. Their line has gone out through all the earth. Their words, you realize that every phrase in here is one of information. One of the titles of the Messiah is the Logos, the Word. There's an intimacy between the declaration of light, the first quote in the Bible, let light be, is all tied together. Their line has gone throughout all the earth, and their words to the end of the world. That's obviously larger than the earth. What's larger than the earth? The solar system, at least, probably a galaxy, you name it. In him he hath set a tabernacle for the sun. The sun has a role, a place, which is as a bridegroom coming out of his chamber, and rejoiceth as a strong man to run a race. The sun is running a race? Yes, because we're going to discover the sun is not a thermonuclear bomb going off somehow. It is a light bulb, a very unusual one that's drawing energy from the plasma and converting it to energy we can use on the earth. His going forth is from the end of heaven, and his circuit, the sun has a circuit. Sure, the Bible says so. From the end of heaven and a circuit to the ends of it. And nothing is hid from the heat thereof. Really? That's interesting. Sounds like thermodynamics to me. And we can go into all this and the locations, but we'll discover when you study the location of the sun, it happens to be in a place and with a dimension that makes discovery possible. If it was closer to the center or further from what, you would not be able to see the star. There'd be all kinds of problems. If you look at the sun in a total eclipse, we discover the corona, and we also discovered the spectroscopy upon which all of astronomy is based. But wait a minute. Why do we have eclipses of the sun? You probably have no capacity to imagine how precise that had to be engineered to have that happen. Let me show it to you. It was designed to be discovered. You have the sun, you have the moon, and you have us on the earth watching this, okay? It turns out, in order to have the moon exactly obliterate the sun alone and let the corona show around it, it has to have a relationship in both size and distance that's precisely right to do that. If it was a little larger, it would totally blot out everything. You wouldn't see anything. If it was a little smaller, what was left would blind you. It happens to be just the right size that it acts like a silhouette of the moon so that you can see the corona. And discovering the corona, you put a prism, you discover, ooh, there's spectra. And from the spectra, you discover you can tell what the chemistry is, and on it goes. So the distance between the eye and the moon, and the distance to the sun, and the radius of the moon and the radius of the sun have to have a relationship, precisely that. And the reason I put D1 plus D2, because I couldn't make the diagram clear to have D2 start with your eye. So the distance from you to the sun is D1 plus D2. That's just an artifact of my diagram here. But the ratio, in other words, the ratio of the distance to the moon to the distance of the sun and the radius of the moon has to be exactly precisely that in order for us to discover the corona. Was that just an accident? I don't think so. If you haven't seen the video, the privileged or the book by Nagalis and this guy called The Privileged Planet, you really want to see that. It may surprise you, the temperature profile of the sun is not what you suspect. You have the photosphere, that's the part you can see, the chromosphere, which is the part that surrounds that, and then the corona. If you look at the temperature profile, I got temperature on the left, and it's logarithmic, and it's in degrees Kelvin. And to the horizontally is the height above the photosphere. The temperature is higher in the corona than it is in the chromosphere or the photosphere. You wouldn't think so, would you? You think it's hot and it would cool as it goes out. No. It turns out it's hotter in the corona as it goes out. Why? Because it's electrical. So you don't get away from this gravity mentality. Let's talk about the voltage profile of the sun. I got voltage vertically here, again against altitude, and we discover that it is pretty steady relatively until it gets to the chromosphere. Then the voltage drops like mad. Visualize that like a cliff that's going off. It's going to accelerate in speed. Okay? And on it goes. And if you're an electrical engineer, you recognize that it's almost identical to the profile of a transistor, a PNP transistor. It's not only electrical, it's very recognizably operational as electrical phenomenon. Let's take a look at the currents in the sun itself, okay? We have, interestingly enough, we have the current entering the sun in what we would call the north and south poles, both entering there and exiting at the equator. Wow, that's not what you'd expect, would you? Huh? And when it does, this is showing you when the main current going through the sun as long as it's increasing in strength, it creates secondary currents that go the other direction with analogous to double layer. But the point is, if it's going in that direction, but if it's going in that direction less fast, so to speak, less intense, those go the other way. Okay? If the main magnetic field starts to weaken in intensity, the secondary surface current will reverse in direction, and the magnetic polarity of the loops will also reverse. These loops are going to respond to whether that main current is increasing. It's the rate of change of that current that's creating the fields that are causing the behavior here. It does not depend upon the direction of the primary current. It depends on, is it increasing or decreasing in strength? Okay? These reversals occur every 11 years. So that's why we have sunspot cycles that are on an 11-year cycle, it turns out. Okay? Here is a picture of the corona, and you can see the plasma sliding along the magnetic field line, and it's a cross-section, if you will, of the corona. And by the way, the size of the Earth on here. The space between these things, the Earth is a speck. Not a speck, it's more than that. Maybe call it, on this diagram here, it'd be about the size of a dime maybe, where this thing here is about 2 feet in diameter. Give you a rough feeling for it. Now, you have the photosphere, and you have a strong looping current will produce a secondary magnetic field that will surround and try to expand the loop. If the current becomes too strong, then the double layer that contains it will be punctured. And the voltage current gradient becomes strong enough, the discharge path will break. The energy stored in the primary magnetic field will be explosively released into space. Piercing the double layer produces what we call a solar flare. See, all this is explained electrically. And here's a picture of it. And here's where I'd love to try to see if I can't show the movie. It's quite dramatic just as you watch this movie go, but it actually shows these things following their paths. It's as you watch these corona flares and so forth, it's obvious as you watch them they're following magnetic paths, electrical paths. They're behaving according to a set of laws which are understood, and from that behavior we don't have all the answers to all the questions, obviously, but it's amazing how much of what we didn't understand about the sun suddenly does make sense, because it's a plasma, and the sun is in effect a very sophisticated transformer to transform the energy it can draw from the fields it's passing through into a form of radiation that can be helpful to the planet Earth. Back to Psalm 19:6, which you started with. His going forth is from the end of heaven, and is circuit unto the ends of it, and there is nothing hid from the heat thereof. The sun is the source of energy for the entire solar system. And all the planets, not just the Earth, get their energy from the sun. Now, every fall, we see the leaves fall. What we may not realize is these brilliant autumn colors are due to the presence of accessory leaf pigments that normally assist the plant in the photosynthesis by capturing specific wavelengths from the sun. These pigments become visible as the leaf dies in the fall. But we need to understand that these leaves have been designed skillfully, and obviously we won't go into all that details here, except to understand they were designed to convert that energy into oxygen and sugar. C6H12O6 is a form of carbohydrates, a sugar. And that is essentially needed by the animals. The animals create the CO2 that the plants desperately need to take, when it takes that energy to create those products. So the plants make not only the O2 that we breathe, it makes the sugars we eat, or the sugars the animals eat when we eat the animals, whatever. But that closes, you understand, the whole thing's been skillfully designed and balanced. So it's not just the universe that's been designed, the whole system we find ourselves in is incredibly skillfully designed. And I love it when people say, gee, the ozone layer, if it changes 1/10 of 1%, it brings cosmic doom. Really? Then who balanced it in the first place, and who maintains its balance today? The more delicate that issue is, the more it proves it was designed not randomly. It's not a result of randomness. Photosynthesis itself means to build with light. Sugar factories are producing millions of new glucose molecules every second. Most plants produce more glucose than they use and store it as starch and other carbohydrates in roots, stems, and leaves. Each year, photosynthesizing organisms produce about 170 billion metric tons of extra carbohydrates. That's about 30 metric tons for every person on the earth. Well, much more happened in the Bible than we really have an idea. Following the fall of man, creation has been subjected to futility and bondage. We learn not only from Genesis 3, but from Romans 8. To reveal himself more clearly, the Creator has given us His Word. His Word is pure, we understand from a number of places. God puts His Word even above His name. That's astonishing when you realize how jealous he is about his name, he puts his word even above his name. And that continues Psalm 19 then. The law of the Lord is perfect, converting the soul. The testimony of the Lord is sure, making wise the simple. The statutes of the Lord are right, rejoicing the heart. The commandment of the Lord is pure, enlightening the eyes. The fear of the Lord is clean, enduring forever. The judgments of the Lord are true and righteous altogether, and it goes on. No, as we understand our universe, we begin to realize it's a plasma. And God said, let there be a firmament in the midst of the waters. Let it divide the waters from the waters. And God made the firmament which divided the waters which were under the firmament from the waters which were above the firmament, and it was so. What do we mean by waters? Mayim in the Hebrew. They translated waters. Is it possible that might be referring to plasmas? And is the figment the boundary between them? Well, we have our little boundaries of reality design here. The truth of man being representing the reach of man, size increasing to the right. We went through the macrocosm, the bigness. We discovered it's finite, and that's studied by the field of astronomy and astrophysics. When we explored smallness, the microcosm, we discovered it's made up of indivisible units called quanta, so we call it quantum physics or subatomic particles. The metacosm that all wraps around this thing, we discover, is a digital simulation. It has finite limits. That is staggering in its implications. That means the real reality is something larger. We use the term spiritual universe, physical. Those are words that don't have, they don't rattle when you shake them for most of us. They're concepts that are a little ephemeral for most of us. But even the scientific American articles that deal with the constancy of our the apparent non-constancy of our constants. But if the constants are changing, and we now know they are, our universe is but a shadow of some larger reality. And that's astonishing. And what's interesting, we've taken the excursion from the macrocosm down through the microcosm with beyond perception, and now this one, in which we introduce the concept of zero-point energy, which ties us back to the real macrocosm isn't the field of astronomy, it's the field of plasma physics. And that's a recent discovery, a recent awareness, and not surprisingly, our popular common literature and the background of most of the editors and journalists are way behind what's really going on. But as the more you understand the frontiers of science, the more comfortable Genesis chapter 1 reads. And I encourage you to do two things. To get a flavor of what we think we know about the universe, but then get a commentary on Genesis that reflects all that, and discover that this collection of 66 books that written by over 40 guys over almost 2,000 years is a package that's been designed in detail deliberately, and that design had to occur from outside the dimensionality of time. It's a message from our Creator to let us know who He is, what He expects of us, and praise God, what we can do to please Him. Through faith we understand that the worlds were framed by the Word of God, so that things which are seen were not made of things which do appear. God bless you.